Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve is the one that you will find on page number 260. Please turn to it. Page number 260, and today is our lesson number 368. Problem number 7 is what we are about to work on. Problem number 7 says triangle PQR and XYZ. We have two triangles PQR and XYZ, and we are told that they are similar. They further go on to tell us that PQ is equal to 6, PR equals 4, and XY we are told equals 9. The question simply is, what's the length of the side XZ? Well, very first thing we need to understand here, the concept that they're testing here, the notion that we need to understand here is, what does it mean for two triangles to be similar, quote unquote similar? What does it mean? What does it mean for the two triangles to be similar? Well, this is a pretty straightforward concept here. Here's what's going on. Say, for example, we have two triangles here. One triangle looks like this, the other one looks like that here. And if we are told that this angle equals to this angle, and if we are told that this angle equals to this angle, and if we are told that this angle right here equals exactly to this angle, then these two triangles are said to be similar. These two triangles are said to be similar. Now what does it mean? It means that the sides of the two triangles are going to be proportional. The sides of the two triangles, are going to be proportional. Proportional. What does it mean? They're proportional? Well, we'll find out in a second. So this triangle, we are told that we have a triangle PQR. Now, another thing that we must understand here, is that there are certain conventions, there is a certain system, there are certain rules that we must obey when we are christening our vertices. Vertices, of course, is a plural of vertex. So here they tell you triangle PQR, and the system, the convention is that, and it's just a convention, but it helps, it makes life easier. If you follow the convention and do as everybody else does, it's much easier, it's more pleasant to drive on the same lane, facing the same way that everybody else is going in the traffic instead of trying to go the other way. Do you understand? Follow the convention, it makes life easier. The convention dictates that we start from the very bottom here, on the bottom left hand corner, and we move in the clockwise direction, naming our vertices. PQR. PQR. And because we first started this from the bottom left, and when clockwise, we have to do the exact same thing here, so that we have the two corresponding triangles. So we have to start here with the X and the Y and the Z. Now we are told that these two triangles are similar. They tell us that these two triangles are similar. What they have told us is that this angle equals to this angle, that angle Q equals to angle Y, and angle R equals to angle Z. Now the sides are going to be proportional. We are told that P to Q is 6. We are also told that X to Y is 9. Oh, I just realized that triangle XYZ is actually supposed to be the larger triangle, because you can see this is 6 and this is 9. It's okay, no need to worry about it. You can broke it, you can handle it, because we are used to it, because all the pictures on the GRE, every single picture on the GRE, they are all not drawn to scale, unless they tell you that they are drawn to scale. So you're used to seeing a situation like this where on purpose they give you a picture where this smaller side they tell you is actually 9 and this is 6, which is okay, we can handle it, we can broke it. So what do we notice? This is 6 and this is 9. That this 9 actually is 1.5 times 6. 9 equals 1.5 times 6, which means this side, Q to R, whatever this side is x to y is going to be 1.5 times q to r. X to y, x to z rather, y to z rather, y to z rather is going to be 1.5 times q to r. But they don't tell you how much q to r is, nor are they asking you anything about y to z. So that side we're just going to ignore. What we are interested in this side, p to r, we are told p to r is 4. P to r is 4. Why? I really did a banged up job of drawing it, didn't I? Because this p to r is also only 4 and this side is 6. It's okay. Pictures are not drawn to scale. Pictures are not drawn to scale. It doesn't matter. We can handle it. We can brook it. P to r is 4, which means x to z has to be 4 times 1.5. And that's all. And how much is 4 times 1.5? 4 times 1.5 is 6. That's all. We are done. 4 times 1.5 is 6 because 4 times 1.5 is 6, of course, because 4 times 1 is 4, and half of 4, half times 4, half of 4 is 2. So of course it is 6. So that's it, we are done. The missing side that they're looking for, x to z, is 6. X to z is 6. Let's take care of these words that I put on the blackboard, the words that we learn in our vocabulary lesson very quickly. The very first word I want to take care of is the word brook. When did we learn about brook in our vocab? Day number 4. On day number 4. And when did we learn about christen? Christen, well, when you watch the video, you'll find out. Day 63. And vertices is not a vocabulary word, it's just a terminology from the math, which simply means plural of vertex. It's the plural of vertex. And what does vertex mean? Vertex, the word vertex is just a very fancy way of saying, a corner. This is the vertex. It has 3 vertices. Of course, triangle is going to have 3 vertices because that's why it's called triangle. It has 3 sides. Therefore, it will have 3 corners, 3 vertices. That's all. If you want to find these videos, just type in GRE vocabulary words, day 4, and it will pop right up. And if it doesn't pop up, try putting my name in it. Just put down Keshwani, GRE vocabulary words, day number 4, and you will see the video. You will learn the word brook along with some other useful, good words that will help you improve your score in the verbal portion of the GRE. You understand? Let's do the next one, shall we? Let's do the next problem. Number 8. I'm going to get out of your way because I've been blocking it all this time. Problem number 8. Oh, I should not have raised the bottom part because we're going to need that bottom part, the definition of similar triangle, because that's what problem number 8 deals with. In problem number 8, we are given triangle NOP. Triangle N. You see again, they're following the same convention. They start from the bottom left and they go clockwise. NOP. Of course, you name your vertices in alphabetical order if you can. Why wouldn't you? This we are told is the right angle. This one we are told is the right angle. This part here we are told is 10. This is 40. And what else we are told? This side we are told is 24. What is it that they're looking for? Excuse me. They're looking for what are the lengths of NO and OP? All right, NO and OP. Let's find out, shall we? NO and OP. Listen, before we deal with this thing, before we start our solution here, it'll be much easier. It will make our life easier if we name these 2 points as well, even though these are not technically vertices of NOP, but these are vertices of this small triangle that I'm showing you here. Let's give them names. So we have NOP. Let's call them Q and R. Q and R. Okay, let's begin our story. Again, this problem also deals with the notion of similar triangles. The triangle NOP, and the triangle QRP are similar. And again, what does it mean for two triangles to be similar? It simply means that the three corresponding angles are equal to each other. And we'll see that they are in fact equal here. Okay, watch what happens. Triangle N here is 90 degrees and triangle Q is 90 degrees. So these two angles are equal to each other, obviously. Angle P, of course, is equal to angle P because angle P is shared by both of these triangles. Both of these triangles share that triangle. And how do we know that angle O is same as angle R? Angle O is same as angle R because what we're dealing with here are two parallel lines being intersected by a third line, in which case, of course, this angle is going to be equal to that angle. This is your angle O and this is your angle R. So these two angles are equal. This angle is equal to that angle. This angle is equal to, well, this angle is the angle that they share with each other, and these two angles are equal to each other, obviously. Therefore, these two triangles are proportional. That's the first part, okay? Because they are proportional, okay, let's first, because they are proportional, then that tells us that if you were to take the proportionality of the side Pn, P to N, where is Pn? Side P to N over N to O, let's call this thing X. That proportionality has to be same as, okay, that proportionality has to be same as P to N, P to N, P to N. So here on the other triangle we have P to Q. P to Q, and N to O. N to O is we calling it X, and this is Q to R. The corresponding side to N to O is Q to R, which is 24. That ratio has to be the same. This ratio has to be, oh, I didn't mean to put down 24. I meant to put down Q to R. Q to R. Now let's put down our symbols here. P to N. P to N is 40 plus 10. P to N is 40 plus 10. Because the ratio of the two sides of one triangle is going to be the same ratio as the two corresponding sides of the other triangles because the sides are proportional. Whatever the ratio exists between N to P and O to N, N to P and O to N, they're going to be in the same ratio as P to Q and R to Q. Do you understand? So this is N to P is 40 plus 10. On the bottom we have N to O, which we are calling X. P to Q we know is 40 over Q to R, which is 24. That's it. We have to solve this inequality to find the value of X. Let's do it over here. Cross multiply. If you cross multiply, you find that 40 times X would have to equal 50 times 24. 50 times 24. Divide both sides by 40. You can get rid of this 40 and X is what you're left with. Divide top and bottom by 10. That get rid of this 0. And divide top and bottom by 4. We can cross out this 4 and 24 is going to become 6. So we end up with 6 times 5. 6 times 5, which is 30. So it turns out that X equals 30. That was the first part. We have to know, oh, so that was the NO. That's it, we're almost done. That was the N to O. Now we have to figure out O to P. O to P is the hypotenuse. Let's take a look at it now. O to P is the hypotenuse. We are almost done. Now we have to figure out the third side. Where did I put my eraser thing? I need the room. Let's put it here. So we're going to redraw this triangle here. N, O, and P. N to P is 50. This side, N to O, we just found out, is 30. The question is, how much is this side? The simple application of Pythagorean theorem will figure out O to P, and we are done. Let's do it here. Where can we do it? Let's do it here. We no longer need this triangle, so let's do the work for this triangle right here. So missing side is the hypotenuse of what we're looking for. Let's call it Y. Let's call it Y so that we don't get confused. We don't confuse ourselves with the symbol X that we used earlier for the other side. Let's call it Y. So it's very simple. Y squared is going to be 30 squared plus 50 squared. That's all. How much is 30 times 30? Well, 30 times 30 is very simple. 30 times 30 is same as 3 times 3, which is 9, and then 2 zeros. Same thing here, 50 squared. 50 squared is going to be same as before. 5 times 5, which is 25, and then we have a 0 and a 0. 2500. 2500 plus 900 is going to be 2500 plus 1000 would have been 3500, so it's going to be 3400. It's going to be 3400, which is your y squared, which can be written as 34 times 100. And therefore y is going to be the square root of 34 times 100, and the 10 is going to come outside. 10 is going to come outside. I left no room for myself to write it. Let's do it here. I'm going to erase this part. And y is simply going to be square root of 100 is 10, and 10 is square root of 34. That's your y, which is what we're calling P2O. That's it. That's what we were looking for. We found it. But the question is, do you have enough practice? Do you have enough skill? Are you ready? Do you prepare yourself well enough to be able to do all of this thing in a matter of 1 minute, 2 minutes at the most? 2 minutes being generous. 2 minutes is being very too generous. You don't have actually 2 minutes per question. That's what you have to do. And you can do all of this thing in the amount of time that is given to you, as long as you know these concepts like this on your fingertips. Do you understand? That's what it is. It's a very simple concept. The concept that they're testing here is very simple, which is the concept of similar triangles. Two triangles are said to be similars if all the three angles or all the three corresponding angles are equal to each other. And if that's the case, the two triangles are said to be similar, and the corresponding sides are proportional. If the corresponding sides are proportional, then if you take any two sides in one triangle, the ratio of those two sides is going to be the same as the ratio of the corresponding two sides in the other triangles. Of course, they have to be corresponding. You can't just willy-nilly pick two sides. Do you understand? That's all. I'll see you tomorrow, okay? Bye now.